We have a question which says that a surface at 250 degrees Celsius exposed to the surrounding. Now, having this as our surface, so this is our surface, which is 250 degrees Celsius. It's exposed to the surrounding at 110 degrees Celsius. Convects and radiates heat to the surrounding. So now our surface here is emitting heat by both radiation and then convection. The convection coefficient and radiation factor so now we have our convection coefficient to be 75 watts per meter squared degrees Celsius, and our radiation factor, which is our view factor mt, is equal to 1.00. If the heat is conducted to the surface through a solid of conductivity, so now it means that we have this block here, and now heat is being conducted from one point to the other point of the surface. Now we see that there is a temperature gradient established here, which is the inner of the solid has a higher temperature than the outer surface of the solid. So now heat is being conducted from the inner to the outer surface, and that is looking at the 250 degrees Celsius. And at the outer surface, heat is being lost to the surroundings by both convection and radiation. So it means that our heat by conduction should be equal to heat by convection plus heat by radiation. So now to find our heat by conduction, we have to use the Fourier's law of heat transfer, which is Ka change in T over change in X, which is Ka dt dx. Now the question asks us to find our temperature gradient. So now this becomes our temperature gradient. And then we have K to be 10 watts per meter degree Celsius. So now 10 multiplying area dt dx. That is the heat by conduction. Now heat by convection, we are supposed to use the Newton's law of cooling, which is HA multiplying T minus T of the bulk. We have our H to be 75. We have no idea of our area, then our T. So from the surface to the surroundings, so 250 minus 110. Now we get our heat of convection to be 75 multiplying 250 minus 110. That gives us 10500 times the area. Now this becomes our heat of convection. Now to find our heat by radiation, we are going to use the Stefan-Boltzmann's law, which is FmcT view factor multiplying Stefan-Boltzmann constant, the area, and then T2 exponent 4 minus T1 exponent 4. So now the question says the view factor is 1. So the view factor can be out. And then with the emissivity, since the question didn't give us any information on that, we can assume that one too should be 1.00. And we get our heat of radiation too. Sigma A T2 exponent 4 minus T1 exponent 4. So for the Boltzmann's law, your temperature is supposed to be in Kelvin because of the exponential. Now at Q radiation becomes 5.67, which is Boltzmann's constant, times the area multiplying T2 will be, so it's also losing heat by radiation. So 250 plus 273 exponent 4 minus to the atmosphere 110 plus 273 exponent 4. Now we get our heat of radiation to be 5.67 multiplying 10 exponent minus 8 multiplying 250 plus 273 exponent 4 minus 110 plus 273 exponent 4. So we get 3000 and 22.14 times A. Now heat of conduction equals heat of radiation plus heat of convection. Now you get the 75 A. Sorry, this. So heat of conduction is this. So 10 A dt on the x should be equal to heat of convection is this 75 A 250. You had the heat of convection to be this. Now 10500 E plus the heat of radiation 3022.14 E. So we can cancel the areas out and then we'll be having 10 dt dx equals 1500 plus 3022.14. Now we can solve for dt dx. Then we get 13522.14. Now 10 dt dx is giving us 13522.14. Now dt dx becomes 13522.14 over 10. And that gives us 1352.2. Now the T dx, which is our temperature gradient, is 1352.2 degrees Celsius per meter.